Okay, so welcome to AI Pest Detection, and we're the Dynamite Dealers. So here you can see the button that says click here to identify the pest, right? So it opens up a file explorer for you to choose a file for you to insert. So for example, let's do a Black Widow. So it gives you the image with a bounding box around it, telling you the species and its confidence level. And then it gives you a link for more information, and it gives you more information underneath to how it can affect you. So bites, and then underneath it gives you how to treat yourself and how to keep them away, and then how to keep them outside of your house. So we can try other insects like, for example, this tick. So here it tells you how to remove the tick and even more facts about it and how to treat yourself. And then let's try another one. Let's do a housefly. So here you can see again with a bounding box.
Okay, so this is our finalized completion matrix for our latest model, and we have 22 species with relatively accurate prediction rates. And earlier in week 2, we had web scraped our images using SERP API and then annotated them using RoboFlow. But however, our confusion matrices weren't great because we had a lot of background classifications and an unbalanced data set. And although we had more precise annotations using polygons, this didn't completely fix the issue. So then we decided to add background images in order to show the program what backgrounds of these insects would look like. And examples of these images we gathered would be like countertop backgrounds, plain backgrounds, granite backgrounds, backgrounds with just like greenery, nature backgrounds like that, and skin backgrounds, which is kind of disgusting. But however, in the end, we managed to successfully train our yellow V5 model with a balanced data set.
Pests have been around for a long time, even longer than human history, and they vary a lot, including in size, from things as small as ticks, things as large as beetles. There are trillions of pests in the world, and it's not very easy to separate one from another, especially within a single category. A lot of these bugs have invaded our homes, making life a lot more difficult. And it's really difficult to solve a problem that you can't identify. So our AI helps identify the most common pests while also giving insight on how to get rid of them.
So some of the challenges we had to get through was the model being accurate in all of the categories. So the first problem came from annotations, and we had to modify the dataset several times, and we had to retrain it like 6 or 7 times. We started with bounding boxes, which got accurate models for bees, but a terrible model for ants and spiders. We converted bounding boxes to polygons for ants and spiders. However, that made the ants and spiders more accurate, but bees got worse, so we had to change almost all of the data sets to Polygon. The second problem was that we were trying to run the training locally because Google Colab wouldn't let us do more than 200 epoch, and our best epoch is 375, so we had to do it on our local PC, and so we had to download CUDA and PyTorch, and then we would have to modify the codes from Google Colab to Visual Studio, which took about 3 days. That was very complicated.
So these are all of the pests that can be detected by our AI model. And to choose which types of pests we would be doing, we chose a bunch of categories that we saw most commonly around our houses. And from each category, we chose a couple of species that were the most commonly seen around the US mostly. And this should let us this should let our AI model be the most useful because it identifies whatever pests most people would see around their houses most commonly, such as Aedes mosquitoes and American cockroaches.
Okay, so this is our GitHub. We had a README. It's gone, I guess. But the README just covered things that we've already been over, our development process, the tools we use, that sort of thing. A big issue we had with the GitHub was because our data set is so large, like 4,000 images, and we also use an extra large model to train it, the data, or it took, well, first, it took a really long time to train. And second, our output was over 100 megabytes, which is the file upload limit for GitHub. So we had to use a whole process using a thing called GitHub large file storage, which stores the file on an external server in order to get it properly working on the GitHub.
So this is an example of an annotation we performed in RoboFlow to minimize background classification in the model and also guide the program with detecting the insect in the image. And here we got two more images that are examples of the model in action with a bounding box outlining the insect, in this case, Western honeybee, and then displaying the species name right there, and then confidence on the top left of the bounding box. Same thing for the wolf spider. And these are all the lovely members of our team who work tirelessly to get the best of our CV model with the time we have. And thank you all.